consider the future value of the position function and acceleration. The position function for future times for t greater than or equal to 0 is s of t equals s of 0 plus integral from 0 to t of bx dx, where s of 0 is the initial position. The velocity for future times for t greater than or equal to 0 is v at t equals v at 0, or the initial velocity, plus the integral from 0 to t of the acceleration a with respect to x. Example, find the position and velocity of an object moving along a straight line with the given acceleration, initial velocity, and initial position. The acceleration at is 20 over t plus 2 to the power 2. V at 0 is 20, which is the initial velocity. And s of 0 is the initial position. To find v at t, v at t is v at 0 plus the integral from 0 to t of the acceleration with respect to x, or 20 plus the integral from 0 to t of 20 divided by x plus 2 to the power second with respect to x. Use the u substitution. That's 20 times x plus 2 to the power negative second with respect to x. That gives us 20 minus 20 over the quantity x plus 2, evaluate from 0 to t. Therefore, we get v at t in the terms of 20 minus 20 over t plus 2 minus 20 over 2. Simplify a little bit more, we get v at t equals 30 minus 20 over t plus 2. Next part, we are going to find the position function. So s at t equals s at 0 plus the integral from 0 to t of the velocity x with respect to x equals 10 plus integral from 0 to t. The Vx that we just obtained is 30 minus 20 over t plus 2 with respect to, supposed to be x, with respect to x. That gives us 10 plus 30x minus 20 natural log absolute value of x plus 2. Lower limit 0, upper limit t. Where s at t equals 10 plus quantity 30 t minus 20 natural log absolute value t plus 2 subtracted by 30 times 0 is 0 minus 20 times natural log of 2. Simplify completely. We will get s at t as 10 plus 30t minus 20 times natural log absolute value of t plus 2 plus 20 times natural log 2 as the position function. Net change and future value. The net change is the difference between the quantity at B minus quantity at A, or the definite integral from A to B of the rate of change of that quantity with respect to time. The future value quantity T or Q at T equals Q at 0 plus the integral from 0 to T Q prime dx. Example, a culture of bacteria in a petri dish has an initial population of 1,500 cells and grows at a rate of cells per day of n prime at t equals 100 times e to the negative 0.25 t. 1,500 cells is n at 0 or initial population. In part A, what is the population after 20 days and after 40 days? The question asks you for n at 20 and n at 40. Part B, find the population n at t at any time t greater than or equals 0. Let's get started with part B, and then we use t equals 20 and 40 to find the answers for part A. So n at t, or the future value of the n, is n at 0 plus the integral from 0 to t of n prime at x with respect to x, or 1,500 plus the integral from 0 to t of 100 times e to the negative 0.25x with respect to x. That gives us 1,500 plus 100 times e to the negative 0.25x divided by negative 0.25, evaluate from 0 to t. The next step, replace t and 0 as the lower and upper limit. 100 and negative divided by negative 0.25 gives us negative 400. Replace the t and replace 0. So e to the negative 0.25 t minus e to the 0, which is 1. Finally, we get n at any t as 1,500 plus 400, or 1,900 minus 400 times e to the negative 0.25 t. That's the answer for part B. And back to part A. So n at 20 is 1,900 minus 400 e to the negative 0.25 times 20, or it's about 1,898 cells. N at 40 equals 1,900 minus 400 times e to the negative 0.25 times 40, or it's about 1,900 cells. Next example, consider the marginal cost C prime at x equals 300 plus 10x minus 0.01 x squared. Find the additional cost incurred in dollars when production is increased from 100 units to 150 units. The additional cost is the same as the net change. The net change from 100 units to 150 units. The additional cost, or the cost at 150, minus the cost at 100 is computed by using the definite integral from 100 to 150 of the rate of change of the cost or the marginal cost with respect to x. The C prime is 300 plus 10x minus 0.01 x squared with respect to x. Find antiderivative 300x plus 5x squared minus 0.01 divided by 3 x to the third power. Evaluate from lower limit 100 to upper limit 150. 300 times 150 plus 5 times 150 squared minus 0.01 divided by 3 times 150 to the power 3 subtracted by 300 times 100 plus 5 times 100 squared minus 0.01 divided by 3 of 100 to the power 3. That gives us the result 69,583 and 33 cents.